Hello everyone and welcome to Network Playroom. This is the 21st video in the Christmas calendar series, and in this video we'll look at the BGP well-known mandatory attributes. So in the previous video we went over the 4 path attribute categories, which are number 1, well-known mandatory, number 2, well-known discretionary, number 3, optional transitive, and number 4, optional non-transitive. So the well-known mandatory attributes must be recognized by all BGP implementations and must be included in every update message. And there are 3 well-known mandatory attributes defined in RFC 4271, and they are origin, AS path, and next hop. Now we're going to study them in detail in this video. So let's start with origin. So origin, again, is a well-known mandatory attribute, and it is generated by the BGP speaker that originates the routing information. And the origin attribute is not changed by any other BGP speaker. Now, on Cisco routers, the origin attribute contains 3 options. So IGP, which is marked with an I, means the route was learned from an internal routing protocol and originated into the BGP process using the network statement. Then there's EGP, which is indicated with an E, and that means that the route originated from EGP, which is now obsolete. So you should never see this, as EGP is not in use anymore, and even the support for it was removed in some older version of iOS. And then finally, there's incomplete, which is indicated with a question mark, and that means that the route originated from a routing process other than BGP and entered BGP by means of manual redistribution. So you would see this in the last column here. This is the show IPGP output, and what it's referring to is this category here. Because if you look at the status codes, there is actually another I, which means something different that we'll not get into in this video. So the IGP may be a little confusing because you might think that this means redistribution, that you redistributed routes from, let's say, OSPF, which is an IGP, to PGP, and that's why it's marked with an I, but this is not true. So the I means network statement. And then E, which you should never see again because it's obsolete. And then finally, the question mark, which means incomplete. This refers to redistribution. So this is what you would see if you redistributed those routes from OSPF to PGP. Now, in terms of path selection, the preference is IGP over EGP over incomplete. So I over E over question mark, or IGP over EGP over incomplete.
One hour later.
So I'm back with a quick correction to the video. Now, when I was talking about the origin path attribute, I mentioned that in terms of the best path selection, the preference is IGP over EGP over incomplete, but I wrote the greater than signs in the wrong direction. So I wrote I over E over question mark, and then I wrote IGP over EGP over incomplete. But this is not true. This is slightly wrong. So how it should be, and let's correct it here. So IGP over EGP over incomplete. It should be this way. Just wanted to correct that and make sure that you don't get wrong information. But now back to the video. Okay, so that's the origin path attribute. Now let's get rid of this one, hide the origin, and let's look at AS path. So the AS path attribute identifies the autonomous systems through which the routing information in this update message has passed. Now when the update message exits an autonomous system, the AS number is prepended to the AS path attribute. But when advertising the routing information to an internal peer, the AS path attribute is not modified. And the AS path attribute is primarily used to prevent routing loops. Because if a PGP router receives an update message that contains the local AS number in the AS path attribute, the update is ignored. So I have a diagram here explaining how the AS path attribute works. So R1 in AS100 advertises this network 1.1.1.0/24, and these are ePGP neighbors, R1 and R2. I should write ePGP here. So when R1 sends out this route advertisement, it's adding its own AS number into the AS path attribute. Now similarly, R2 and R3 are also ePGP peers. So when R2 sends this route advertisement to R3, it prepends its local AS into the AS path attribute. So the AS path attribute now contains both AS200 and 100. But when R3 advertises the route to R5, because they are iPGP or internal neighbors, the AS path attribute does not contain the local AS or AS345. Because as mentioned, this is a routing loop prevention mechanism. So if R5 would receive this route with AS345 added to it, it would ignore the update and it would not install this route into its routing table or in its PGP table. So that's why it is not included when you advertise routes between iPGP neighbors. Okay, that's it about the AS path. Now let's look at the next hop attribute. So the next hop attribute defines the IP address of the router that should be used as the next hop to the destination listed in the update message. Now, when sending a message to an internal peer, the PGP speaker should not modify the next hop attribute unless explicitly configured to do so with the next hop self command. But for external PGP peers, the next hop IP address is the IP address of the interface that the PGP speaker uses to establish a PGP session to its peer. So let's look at that on the diagram here. So again, R1 is advertising its local network. Now, here, the ePGP peers, or the peering, is established using the directly connected interfaces. So these. And that is why the next hop IP address is 10.1.12.1. But here, when R2 advertises this route to R3, it modifies the next hop to its local IP address. Again, these ePGP neighbors, or the peering is established using the locally connected interfaces or directly connected interfaces. Now the difference here is that when when R3 advertises the route to its iPGP neighbor R5, the next hop is not modified. So the behavior is different depending on whether the route is advertised to an ePGP or an iPGP neighbor. But if you wanted to change this to this local address, you could do it with the next hop self command. Okay, but now let's look at these attributes in a packet capture. So as usual, I have a packetlife.net capture open here. So let's just go to an update message. Not zoom in, I wanted to click on it. There we go. So we should be able to see these path attributes in all update messages that we'll look at. So here's the origin. It says IGP, which means that this route was learned via network statement. And here's the AS path, which is empty. So this means that it's a local route, or when inside its own AS, because nothing has added to it. The AS number is prepended when you advertise to external PGP peers. And then we have the next hop, which is 3.3.3.3. Whoops. So this is the IP address that the router uses for the PGP session. So, and then if we look at another PGP update message, we should see these three attributes again. Well, there are other attributes as well, but these are the well-known mandatory ones that are included in each update. Now here you can see the origin type is incomplete, which means that the routes were learned through redistribution. And then again, the AS path is empty. And then finally, the next hop is 3.3.3.3 again. And actually, let me see if there was an ePGP packet capture here, because we should be able to see something in the AS path attribute. Let's check that. Okay, update message, path attributes, and here you can see AS 65,200 in the AS path attribute. So this route was learned from this AS. And as you can see here, this routing update or this update message doesn't contain the same path attributes as were on this one. For example, here you have local preference, this one, but it's not present in this update. But yeah, you can have a look at these packet captures yourself and get familiar with at least these three path attributes, because they are the most important ones. But we'll probably look at other PGP path attributes in other videos. So thank you again for watching, and I'll see you in the next video.